So in this question, we've been told that a uniform rod AB has a length of 5 meters and a weight of 100 newtons. So we are given a diagram in the question, but I would always want to produce my own diagram so that I can annotate it fully and just get a better understanding of what's happening as I'm producing that diagram. We're then told that the rod rests in a horizontal position on two smooth supports, P and Q. We're told that AP is 1 meter, so I'm going to add that onto the diagram. And since we were told that this is a uniform rod, I'm going to be able to model the weight right here at the middle, which is 2.5 meters away from the left-hand edge. So I can add in these lengths here. I know that this is going to be 1.5, but this is actually unknown. We don't have much information about point Q. So that length there, for now I'm going to call it X. On the right hand side of Q, I could call that 2.5 minus X, but I'm not sure I'm actually going to need that for such a simple question. So let's continue. We're then told that the reaction force of the rod at P is 40 newtons. So I can add that 40, and there's a second reaction force here, which is just going to be unknown. So I'm going to call this reaction Q. So R with Q as a subscript. My diagram is as complete as I've been given information for. We should be able to go ahead and solve any of the unknowns that the question wants me to. In part A, we're asked to determine the magnitude of the reaction force on the rod at Q. So all I'm going to need to do is to resolve vertically. So all the upwards forces should equal all the downwards forces. So 40 plus reaction at Q equals 100. And I should have labelled this onto the diagram. The rod itself weighs 100 newtons. Just some simple rearranging from here. The reaction at Q must be 60 newtons. In part B of the question, we're asked to calculate the distance AQ. So I'm going to take moments from P. So I'm just going to put a big dot here so I can calculate the moments from P. The moment generated by the weight is going to be the distance, 1.5 meters, multiplied by that force of the weight, which is 100. So that's going to be a clockwise moment, while the anti-clockwise moment, its distance from our pivot point is 1.5 plus x, and I'm going to multiply that by the 60 that we just found out. We know that the force of the reaction at Q is 60 newtons. So now I've set up this equation, it's just about simplifying and rearranging to find a value for x. So 150 equals 90 plus 60x, rearrange, and actually nicely, 60 equals 60x, x must equal 1. The distance from where we've modelled the weight to point Q is going to be x, and x we know is 1. Okay, we found x, but we haven't answered the question. The question wanted to know the distance AQ. So I should have actually labelled this on the diagram. A is on the left, B is on the right. AQ is going to be 1 plus 1.5 plus the x value of 1, and altogether it's 3.5 meters.